Scientists at Massachusetts General Hospital have created a brain in a dish, if you will, a Petri dish. They've developed a Petri dish with human brain cells that produce the telltale structures of Alzheimer's disease. The researchers resolved a long-standing problem of how to study Alzheimer's and research drugs to treat it. Before this, scientists utilized mice, a method with significant drawbacks. Yeon Kim is a neurology professor at Massachusetts General Hospital and Harvard Medical School, and he is also a lead researcher in this study, and he's joining us from there. Dr. Kim, welcome to Arise America, and first of all, congratulations. This is really groundbreaking. It really has to have set the neurology world on fire, huh?
Thank you so much. I mean, we got a lot of attention nowadays, but we are doing what we have been doing, so we are very happy. We provide another model which can help to develop the drugs for the Alzheimer patients.
So you have created these cells. Explain to us, if you will, in words that we can understand, Dr. Kim, how you've created, if you will, this brain in a dish and how it has the characteristics of a patient with Alzheimer's.
Yeah, as you introduced, it's very important to have a right model system if you want to develop drug, because we cannot just treat all the chemicals on patients. So currently the mouse model is most major model in Alzheimer's disease. But what he found is that human neuron system can be several advantages of testing these drugs. And what we did first time is we tried to reconstitute those brain network in a dish by using three-dimensional gel system. So our human neural cells in our Petri dish is actually making connection in three-dimensional gels, and then they can communicate each other. One thing we made is we made those cells expresses those genetic mutation which Alzheimer patient has. And these cells we found in these three-dimensional gel system developed those pathologies which already has been shown in Alzheimer patient brain, which is so-called the amyloid plaques and neurofibrillary tangles. That's what we, for the first time, found in the in vitro system.
Let me ask you this, Dr. Kim, which is more significant in terms of Alzheimer's research? Having this model, this brain in a dish, if you will, to be able to understand the disease, or to be able to find a cure or at least a treatment for the disease?
In this case, we can say both, because that previously there's mouse model, other models, we cannot study how amyloid plaque turns into the tangles. And that's a kind of big mystery box. Already we proposed there will be some connections, but there are no models available previously. So now our model showed for the first time these connections. So now we can study how this can be connected to each other. And that's a nice thing about the pathological mechanism side. And for the drug screening, definitely this system should be much more faster and much easier to test many number of drugs. So that's what we are very ambitious about right now, because in the previous mouse model, it takes more than a year to test one drug. But in this case, we can grow these 3D human gel-like structure in very small dishes, 96 wells, and then we can test them in 3 or 4 months. And then that's actually way faster than the previous method.
Yeah, that's absolutely incredible. How expensive is creating these cells, and how long does it take?
So it's not really expensive. It's just that we are growing cells for 3 months, and then I can say that it's we approximate. It's definitely 1/10 of the cost required for the mouse maintenance, all the things. And then it generally takes about, we need to start growing cells. We have all the frozen cell stocks right now, which represent Alzheimer patient and control. And then we can grow them, differentiate them for about 2 months. And then we treat the drug about 2 or 3 weeks, and then we can get the results.
Are there any big limitations to using these cells to further research on Alzheimer's, which of course is happening, as we say in science, in vivo? This is in vitro.
Yeah, that's the things. I can say that this model is for the first time recapitulate amyloid plaques and tangles. But it's hard to say that we reconstitute what's happening in the brain of Alzheimer's patient. So because one of the limitations of our system is our system doesn't have microglia cells, which is major immune system in the brain. And then that is previously proposed very important role in Alzheimer's pathological changes. and then our system doesn't have it. So I can say that there are a lot of things to be improved for the future for more closer brain model. But with just current model, excited because we could not see the tangled petals together with plaque in the previous model. So maybe we can find a new drug which can regulate or decrease these two petals at the same time, which we cannot do it with the mouse models.
Yeah, it is indeed so exciting. Probably almost everyone that's watching this show has been touched in some way by someone suffering with Alzheimer's. So it is certainly a great step forward. Again, congratulations, Dr. Kim, and thanks for coming on to explain it to us.
Thank you so much.